Sometimes people, and I include myself here, will contrast functional programming with object-oriented programming when they really mean data type-oriented programming versus object-oriented programming. That is, having a data type and writing functions that receive a variant and figure out which one it is, versus having objects and sending different operations to that object depending on which operation you want. Right? And that's a choice of organization, and it affects whether you can easily add variants or operations more easily. On the other hand, sometimes people will say functional versus object-oriented, and they're really talking about something different, which is a choice of language primitives. Our languages have been functional in the sense that there was first-class functions as a core part of the language, and we could build a lot on top of that. Another alternative is to not have first-class functions, but only have objects, and then you can build many things on top of objects as well. You can see that in our current representation of objects, we're using hash tables and we're using functions, and in fact, we're still using first-class functions in a significant way. When our area method refers to w, then it's a w that was passed in to the enclosing function. And so we're relying on the ability to put functions inside of functions and the underlying implementation of closures to be able to look up that w. So if we wanted to get rid of that, if we want to reduce our use of first-class functions to get to a pure object system, in the sense of what are the primitives, right? Then we could write things more like this, where we have a hash table for methods, and we also have a hash table for fields, where we map w to the value for w and h for the value of h, and then each of our methods, in addition to the arguments that they used to take, such as the number n for bigger than, they always also take a this argument, where the this argument is the whole closure itself. The whole object itself. And then this get operation is going to be a hash table lookup on the list coming back in. So we'll see that unpacked in a minute, but I want to point out that this thing that I've written here could be written equivalently like this, where we have functions that are only at the top level, and we sort of refer to those here in a C-like way where you can pass function pointers around, but we don't have nested functions. And in fact, I've made this outer thing a macro. Rectangle is not a function at all, so that I'm relying even less on functions here. I need to explain this get operation and how that works a little bit more. So what we're going to say is that an object, such as a shape, is going to be a list of two hash tables, one for the fields and one for the methods. Right? And we're going to have this get macro, which takes an object and a field name, and it pulls out the first hash table from the object. Remember, an object is going to be this list, so the first hash table is here, that's the fields, and does a hash ref on that. So get is like the dot operator for looking up a field in Java or JavaScript. It takes an object and a field name, and it gets quoted by the macro to look it up from the hash table. And so that's why the methods here need to receive a this, and they can use get to access the w and h values. At the same time, send, we saw this before, send takes an object and a method and extra arguments. It looks in the second hash table of the object, right? So this one, to find a method name. And now when we apply that function, so this parenthesis is applying the function, we not only pass the arguments, but we also pass the object itself. So that's why I've bound it to a local name here, so that I only evaluate the object expression once. I use the object the first time to pull out this hash table, and the second time I pass it into a method, so that the this argument for area, for example, this argument corresponds to the whole list. And when we do get on this, that means we're getting out of the hash table, which is the first thing in this list, and so on.